JJ Math. Okay, so let's talk about logs. So in many videos I've mentioned this word, and I know some schools teach it to the students and some schools leave it till the end of chapter 2 where it's actually in the syllabus. But the quicker you can learn it, you can just have an extra tool in your back pocket because there are certain sums in this chapter that you can't do without logs. So when do you use a log? You use a log with a geometric pattern if you need to work out n. So whether it's Sn or Tn, if they give you the answer and you need to figure out how many terms or which term in the sequence would be equal to, then you use this, but remember only with geometric patterns. So it's all about exponents. So if we look at this block to the left, we know that 2 to the power 5 is equal to 32, and 3 to the power 4 is equal to 81. Now I want you to see where is the base and where is the answer in that little equation. Okay, so now if we look at the block to the right, we use logs if we don't know what n is. So in the first little equation up there, I wrote 2 to the power n is equal to 64. So I can use logs to see what must the exponent be so that the answer is 64. Now how we would rewrite this, so if I say 64 is equal to 2 to the power n, I would put in a log, and now I want you to please look at your calculator. There are 2 log buttons on your calculator. Please use the top one with 2 little blocks next to it. So the bottom block you call the base, and the other block is called the number. So whenever I use logs, there's a little rhyme you can remember. The base stays the base and the other 2 swap around. So the 2 was the base, that becomes the small number, and the other 2 swap around. So now if I type this in my calculator, you will see it just tells me it is 6. So what I asked the calculator is, what must the exponent of the bottom number of 2 be in order to get an answer of 64? And the calculator said it must be 6. Let's just try the other one. Okay, so 2, 4, 3 equals 3 to the power something. Now, if I want to do this with logs, I'm going to say log, the base stays the base, and the other 2 numbers swap around. So if I type that in, the answer will be 5. N should equal 5. Okay, I hope that makes sense. It's really as easy as that. It does get a bit more complicated in other chapters, but in recent years, the log sums aren't really difficult, especially with patterns, just stays like this. But let's do a few so you can actually see where I would use it and how the bigger question would look and how this fits in. Okay, so 1024 is equal to 2 to the power something. I can immediately write a log. I can put in the base because the base stays the base and the other 2 swap around. 1024. If I type this on the calculator, it would say the answer is 10. So I could have also done this with the shift fact function. So if I said 1024 equals shift fact, it would tell me 2 to the power 10 is equal to 2 to the power x, and therefore 10 is equal to x. So you can really decide with many of these sums which way of doing it you like most. So there are a few questions that only works with logs. So many students tell me, I want to learn one method that works with everything. That would be logs. Question B, what must the exponent be for 2 over 3 to turn into 32 over 243? If I just go with logs, I can say log, the base stays the base even though it's a fraction, and the other 2 swap around. Okay, so 32 over 243, calculator tells me the answer is just 5. Okay, so just a side note on logs, whenever you put in those numbers, you are not allowed to use minuses. The log function will give you an error if you type in minuses there. So if you have a sum with minuses, make sure your algebra is correct, and when you get to this point, especially if both sides have a minus, just ignore the minus, get the answer, and then at the end, you can just see what the calculator says the answer would be. Let's look at these 2 questions. So I took this from previous videos where we used the shift fact function, but I also said you could use logs. So let's look at just what I meant there. How many terms are there in the sequence? Okay, so firstly, I need to figure out, is this Sn or Tn? And is this arithmetic or geometric? Now I can see there I'm minusing 920. There I'm not minusing 920. So it's definitely not arithmetic. But if I say I'm halving the terms, then definitely I'm multiplying by a half, but it also has a minus, and I'm multiplying by a half, and the sign change, so it must be a minus. Therefore, I know that A would equal 640, R would equal minus a half, and then I can use the Tn to figure out what is n. So I'm going to go for Tn is equal to A times R to the power n minus 1. They gave me the value of the last term, so I can just put that in there. 640 minus a half to the power n minus 1. And now I can just divide both sides by 640. And then my answer would be minus 1 over 32768 is equal to minus a half to the power n minus 1. Okay, so now if we want to go logs, we have a little problem because I said you are not allowed to have minuses in the log function. So I am going to ignore the minuses for now because what probably happened is an even exponent cancelled the minuses for this to still be true. Okay, so let's just look how I would write it on paper. So log, the base stays the base, and the other two swap around. So 32768 is equal to n minus 1. Calculator will tell me if I put in that big log that n minus 1 is equal to 15, and therefore n is equal to 6. Let's try the last one. How many terms should be added together if that sequence equals 2049 over 4096? Firstly, I can see this as geometric. Whenever it's fractions, the denominators are not the same and all of that. 99% of the time it's going to be a geometric. So a is equal to 3 over 4. R is equal to term 2 divided by term 1. And in this case, it would be minus a half again. Now, I just sub into the Sn formula to figure out what is n. So I already can see that the value of Sn that they gave me is that one. 4096 is equal to, remember this formula, the a goes in front, bracket minus a half to the power n minus 1 all over minus a half minus 1. So in this sum, I want the denominator on the right to be eliminated. So I'm going to multiply that over the equal sign to the left. Minus a half minus 1 gives me negative 3 over 2. So I'm going to multiply 2049 over 4096 with minus 3 over 2. Let's just write the rest because that didn't go away. If I type that on my calculator, I get minus 6147 all over 8192. So I'm going to divide that 3 over 4 to the left. According to the calculator, this is minus 2049 over 2048. I am going to plus the 1 from the other side and then just see what that gives me. And it actually gives me minus 1 over 2048 is equal to minus a half to the power n. So here I can see it is a half to the power n, okay, with a minus, and then the other side was also minus a half to the power something. So let's just see how the log would look for this question. So if I rewrite this into logs, I would say equal. I'm going to do the log. The base stays the base, but remember I don't write the minus. The other two numbers swap around, so n would be on the left, and then the 1 over 2048 would be on the right. And if I type that in, it just says the answer is 11. Okay, so that's how logs work. How do you feel about it? Does shift fact feel easier, or do you think logs is going to help you more? You are free to choose because after chapter 2, the entire country's matrics know how to use logs or are taught how to use logs. You can just practice it and decide which method you like the most.
If this video helped you, please like and subscribe.
JJ Math.